Hello everyone, and welcome back to the channel. I'm an aircraft engineer, and on this channel, we break down aircraft systems in a simple, clear, and practical way. We are going to look at aircraft communication system and understand how it works. Before we begin, please subscribe to the channel and tap the bell icon.
You know, when we think about an airplane communicating, we usually picture a pilot talking to air traffic control, right? But that's just the tip of the iceberg. What's really going on is this constant, incredibly complex conversation happening both inside and outside the plane. So let's get into it. So how does a massive airplane actually talk? I mean, really talk. It's so much more than just a voice on a sometimes crackly radio. The reality is way more intricate and honestly, a lot cooler. Because what we're really talking about here is a vast digital nervous system. It's this incredible network that connects the plane to the ground, to satellites way up in space, and even connects different parts of the aircraft to itself. It's all designed to ensure safety, efficiency, and comfort from the moment you leave the gate to the moment you arrive. So here's what we're going to cover in this explainer. We'll see how it's so much more than a radio. We'll look at how a plane talks to the entire world. Then we're going to dive into that internal nervous system. We'll see how the cabin is managed. And finally, we'll look at the ultimate fail-safes that are built in for everyone's safety.
Okay, so at its core, you can think of aircraft communication as being split into two big halves. You've got the external systems that talk to the outside world, and then you have the internal systems that manage everything happening inside the aircraft itself. Let's start by looking outward.
Right. This external network, it's all about keeping the aircraft connected with air traffic control, with ground stations, and with its own operations center, no matter where it is on the planet. And this is done using a trio of really powerful radio technologies.
And what's so smart about this is how these systems work together to create this seamless web of communication. See, VHS is your workhorse. It's for that crisp, clear, line-of-sight chat that's perfect when you're near airports or flying over land. But what happens when a plane flies out over the Pacific? Well, it's way out of VHF range. That's when HF kicks in, literally bouncing its signals off the ionosphere for those long-distance conversations. And for that truly global, always-on coverage, modern jets use SATCOM, linking up with satellites for both voice and data. It basically ensures the flight deck is never, ever out of touch.
And it's not just about voice. There's also a ton of data flying back and forth. That's where ACARS comes in. ACARS is pretty much the plane's own private text messaging service. It's automatically sending these short messages about flight progress, engine health, you name it, back to the airline. It keeps everyone on the ground totally in the loop, all without the pilots having to say a single word.
So while the plane is busy talking to the world, it's also having a really complex conversation with itself. This is the plane's internal network, this hidden digital backbone that runs pretty much the entire passenger experience. It's called the Cabin Intercommunication Data System, or CIDS for short. So this diagram gives us a peek at the architecture. At the heart of CIDS, you've got two main computers, and they're called directors. Just think of them as the twin brains of the whole operation, which means there's always a backup. They send commands out to these smaller units called DEUs, decoder/encoder units, which act like local managers controlling specific things like the lights and signs all throughout the cabin.
So, what exactly does this CIDS nervous system control? Well, it turns out, pretty much everything you see and hear as a passenger is being managed by this one network.
I mean, it's a huge list. CIDS is in charge of all the passenger signs, fasten seatbelts, no smoking, all of them. It controls every single one of the cabin and reading lights. It runs the PA system for announcements, the interphone system so the crew can talk to each other, and yeah, even the boarding music. And most critically, it also controls the evacuation signaling system.
Now, the crew isn't sitting there typing computer code to make this happen, of course. They interact with CIDS through these really slick control panels. The main one is this, the Forward Attendant Panel, or FAP. It's basically the command center where the cabin crew can control lights, make announcements, and check the status of the entire cabin.
And here is where it gets really smart. The CIS director isn't just taking commands from the crew. It's also getting live data directly from the plane's main systems. So, for example, when the landing gear is lowered, the system knows to automatically turn on the fasten seatbelt sign. It's this perfect blend of manual control and intelligent automation that makes the whole thing feel so seamless.
Now, with all of this communication flying around, safety is absolutely paramount. The whole system is designed with multiple layers of redundancy, but on top of that, there are also dedicated communication systems that exist purely for the worst-case scenarios.
The one we've all heard of is the Cockpit Voice Recorder, or CVR. But this is not just some simple tape recorder. It's a heavily protected, crash-survivable memory unit that records every single sound in the cockpit, pilot conversations, radio calls, even clicks and alarms, on a continuous loop. It provides absolutely invaluable data for accident investigators.
And to give you a sense of just how critical that data is, check out what it takes to erase it. It's not just hitting a delete button. First, the aircraft has to be on the ground. Second, the landing gear has to actually sense the weight of the plane. And third, the parking brake has to be on. This multi-step protocol makes sure that the recording can never be erased by accident, especially not in the air.
And if everything else goes wrong, if all other communication is lost, there is one final voice, the Emergency Locator Transmitter, or ELT. It's a beacon that's designed to automatically activate after an impact, sending out a distress signal to help rescue teams pinpoint the aircraft's exact location. So, you see, a modern aircraft is so much more than just a flying machine. It's a highly intelligent, constantly communicating hub. It's this incredible, complex network of systems, all talking to each other and to the outside world, working together to ensure a safe and efficient flight. And that brings us to one final thought. We've seen how complex these networks already are, with a human crew right at the center of it all. But as we move towards a future with more autonomous aircraft, you have to wonder, how will these vital communication systems need to change to handle even more data, more decisions, and a whole lot more responsibility? That really is the next frontier in our connected sky.
Please subscribe to this channel and turn on the notification bell. More aircraft system videos are coming soon. Thank you for watching.